Hello everyone. The Deluge system is an open system, and its commissioning differs significantly from that of wet or dry alarm systems. In the following, we will take the direct flow diaphragm Deluge alarm valve as an example to explain its structural principles and step-by-step commissioning procedures. The direct flow diaphragm Deluge alarm valve operates by the lateral movement of its diaphragm to open or close the valve. Internally, the valve is divided by the diaphragm into a control chamber, a water outlet chamber, and a water inlet chamber, with the control chamber connected to the water supply, such as a fire water pool. In a near-normal working state, the control chamber is in communication with the water supply side, such as a fire water pool, and the water pressures in the control chamber and the water inlet chamber are equal. Due to the difference in effective areas exposed to water on the upper and lower sides of the diaphragm, a ceiling pressure differential is established in the balanced state, ensuring that the valve disc remains tightly closed. When the valve in the initiating pipeline is opened, the water replenishment into the control chamber is less than the discharge, causing its pressure to drop rapidly. The water pressure in the inlet chamber then drives the diaphragm to move, and the Deluge valve opens. Simultaneously, water flows into the alarm pipeline, triggering the hydraulic alarm bell, activating the pressure switch, and interlocking to start the fire pump. Understanding the structural principle of the Deluge alarm valve is fundamental to successful commissioning. Next, we will outline the commissioning procedure step by step based on its operating principle. Before beginning the commissioning and acceptance test, prepare all the necessary tools, such as a steel tape measure, screwdrivers, a multimeter, a stopwatch, a sound level meter, and so on. 1. Remote manual start function test for the Deluge alarm valve. On the automatic fire alarm and interlock control panel in the fire control room, set the bus to manual permit mode. Then, by pressing the corresponding solenoid valve control button, remotely open the solenoid valve on the Deluge alarm valve, thereby achieving direct remote manual activation of the Deluge alarm valve. 2. Emergency mechanical start of the Deluge valve. By opening the manual valve on the Deluge alarm valve, water in the control chamber is discharged, directly triggering the opening of the Deluge alarm valve. 3. Automatic start function test under fire alarm interlock. Under automatic conditions, trigger an alarm by having 2 or more independent temperature fire detectors in the same alarm zone sound, or by combining the activation of 1 temperature fire detector and 1 manual fire alarm button to send an alarm signal. This interlock will open the Deluge valve. The solenoid valve in the initiating pipeline is activated, causing the control chamber pressure to drop, the Deluge alarm valve to open, and water to flow into the alarm waterway. Consequently, the hydraulic alarm bell sounds, the pressure switch activates, and the fire pump is interlocked to start. On the fire alarm and interlock control panel, feedback signals, such as the solenoid valve activation, pressure switch operation, and fire pump startup, should be displayed. Standing 3 meters away from the hydraulic alarm bell, use a sound level meter to measure its sound intensity, which should not be lower than 70 decibels. Also, use a stopwatch to time and observe the startup time of the Deluge alarm valve. For Deluge alarm valves with a nominal diameter of 200 mm or less, the valve should start within 15 seconds during commissioning. For those with a nominal diameter greater than 200 mm, the startup time should be within 60 seconds. Additionally, during the Deluge alarm valve test, when the alarm water pressure reaches 0.05 megapascal, the hydraulic alarm bell should sound. It is also important to note that in some areas where installing a fire alarm system is inconvenient, a liquid, water, transmission pipe may be integrated, and a closed sprinkler on the wet transmission pipe network is used to detect a fire, thereby triggering the Deluge system. In such cases, the automatic startup function of the Deluge system can be tested by simulating the operation of the closed sprinkler on the water transmission pipe or by activating the terminal water test device at the most unfavorable point of the water transmission pipe. The above describes several functional tests for the startup methods of the Deluge system. Mastering the functional tests of the Deluge system not only demonstrates professional competence but also embodies the practice of the safety first, prevention-oriented principle. Fire protection personnel should approach every commissioning phase with rigor, combining the professional ethic of striving for excellence with the mission of serving the country through technology. In team collaboration, strengthen the sense of responsibility to ensure that the system complies with national fire protection regulations and provides reliable security for building a safe society.